Hello guys, I'm Rupa. Now I will be talking about the next part in an atomic structure, which includes the second and the third type of subatomic particles, which are protons and neutrons. If you haven't watched my first video on atomic structure, please do watch and come back here for better understanding. Now let's start with the discovery of protons. The presence of negatively charged electrons in an atom suggests that it must contain a positively charged particle as well. Otherwise, an atom would be electrically neutral. So, these positively charged protons were discovered by Goldstein, a German scientist. So, he performed a series of experiments with a discharge tube fitted with a perforated cathode. Here, children, you may observe in the diagram a perforated cathode means with small holes to allow the passage of positive rays. A ray which was just the opposite to the cathode in all respects was emitted from the anode. This ray was named as anode ray. The anode ray consisted of positively charged particles called protons. So, these you may observe through the diagram, children. So, next comes to the properties of protons. Here, the properties of protons includes the mass of a proton was calculated being equal to the mass of an atom of hydrogen, that is 1.672 into 10 to the power of minus 24 grams. Children, already we discussed about in the electrons, the mass of an electron is also being calculated on the basis of an mass of an atom of an hydrogen. In the same way, here the mass of a proton is also calculated in the that is, it's being equal to the mass of an hydrogen atom, that is 1.672 into 10 to the power of minus 24 grams. The second one, the positive charge on a proton is equal to the negative charge of an electron, that is 1.602 into 10 to the power of minus 19 coulombs. Because, say, the atom is an electrically neutral, hence both the positive charge and the negative charge must be equal. So, further experiments proved that all elements are composed of protons and electrons. However, no two elements contains the same number of protons. For example, hydrogen, helium, lithium, carbon. So, all these elements which contains a different number of protons. For example, hydrogen contains 1 proton and helium contains 2, lithium 3, carbon whereas 6. So, in this way, no element will contain the same number of protons. And next comes to the Thomson's model of an atom here. So, Thomson's model. J.J. Thomson, he worked out a model which is known as a plum pudding model. According to this model, an atom is a positively charged sphere in which electrons are embedded. Just like dry fruits are embedded in a distributed. That means dry fruits are distributed in a pudding. Same way, he described his model that the electrons are embedded in the plum pudding model of an atom. So, in this model, he describes that the total positive charge of an atom was equal to the total negative charge of the electrons. So, this theory also says that if an atom would be negatively charged if it gains electrons and it positively charged if it loses the electrons. So, study about these things. So, like ions, how the formation of ions will take place if the ion is a negatively charged, so that it gains an electrons. It means that it gains electrons. If an ion is positively charged, it loses the electrons. So this, he says that pudding model gives all these observations, children, but this Thomson's model was not accepted. So now comes to the discovery of electrons. Here, discovery of electrons. In 1911, Lord Rutherford, a scientist from New Zealand, conducted a series of experiments in order to find out the arrangement of electrons, protons in an atom. So, this experiment of a small positively charged nucleus at the center of an atom. So, Rutherford's alpha particle scattering experiment. So, children, you may observe in the diagram here. So, the Rutherford, how he proved the presence of a nucleus here. So, he used here a very thin sheet of gold. So, he bombarded an alpha particles in an evacuated chamber. So, he used a thin sheet of gold in an evacuated chamber. He used the thin sheet of gold. So, the alpha particles hit the thin sheet of gold in an evacuated chamber. So, what are the observations? The first one is the most of the alpha particles pass straight through the foil without any deflection from their path. Children, you may observe that the most of the rays are alpha particles traveled in a straight path. And the second one, a small fraction of them were deflected from their original path by the small angle. And next one is only a few particles are bounced back. So a few particles are bounced back. On this basis, the Rutherford has given few conclusions. So what are the conclusions here? Most of the space in an atom was empty because alpha particles went straight. See, already explained that a few alpha particles, so they passed through the straight through the foil without any deflection from their path. Next one is there was a heavy positively charged mass in an atom which caused deflection in a small fraction of alpha particles. The third one is the positively charged mass is very small and it is centrally located because only a few particles bounced back. It was named as a nucleus of an atom. The first suggested an atomic model. So this atomic model, so is consists of mainly two parts. What are those two parts here? The centrally located nucleus and the outer circular orbits. The first one, the centrally located nucleus. So what does it say actually? The centrally located nucleus is centrally a positive charge it is there. So positive charge is concentrated at the central. So the entire mass of an atom is concentrated at the center of an atom. So that is nothing but the nucleus. Nucleus is very small when compared to the size of an atom as a whole. So if we consider a circular playground, let us keep one football at the center of the playground so that you may imagine the size of an playground and the size of the football. So this shows that the center part, the nucleus part, the size of the nucleus is very small when compared to the size of an atom. So the second one is the outer circular orbits. Outer circular orbits. What do we find actually in the outer circular orbits, children? Here in the outer circular orbits, electrons. So the electrons revolve in a circular orbits called shells in the space available around the nucleus. Okay, an atom is electrically neutral, that is the number of protons and the number of electrons present in an atom are equal. As the electrons revolve in circular orbits, Rutherford compared his atom, the model of an atom, to the solar system. That is, sun is at the center and the planets are revolving in a circular orbits around the sun. In the same way here, the nucleus is at the center The electrons are revolving around the nucleus. It is clearly shown the model of an atom and the model of a solar system. You can observe children here. So this shows that the electrons revolve around the nucleus in a particular orbit called shell. And next comes to the third subatomic particle, that is the discovery of neutrons. The mass of an atom was in fact considered to be entirely concentrated within the nucleus in the form of protons. Since the mass of an electrons are very negligible, but when it was discovered that the nucleus has the greater mass could be accounted for by the protons alone, then it was realized that there must be a third subatomic particle which was present in the nucleus. So it has neither positive charge nor the negative charge. So, the James Chadwick in 1932, he discovered the subatomic particle called neutron, but it doesn't contain any charge. So, next comes to the properties of neutrons. The mass of the neutron is slightly more than that of the proton, that is 1.676 into 10 to the power of minus 24 grams compared to 1.672 into 10 to the power of minus 24 grams. Children, the mass of a neutron is slightly greater than that of the mass of the proton. Next one, electrically, a neutron is neutral, that it has no charge. Since we already know that an atom is electrically neutral, already electrons are negatively charged and the protons are positively charged. So that it says that, and also so many experiments and the theories has proved that the neutron doesn't contain any charge. It is neutral. Next, third one, atoms of same element may differ in the number of neutrons, leading to the formation of isotopes. Here, the formation of isotopes. Guys, you don't need to worry about the isotopes. We'll learn about it in a later classes. An atom of an hydrogen contains only one proton and one electron, but no neutron. All other atoms have all the three particles. All other elements have all three particles. Children, I hope everyone understand about the discovery of protons and neutrons and their properties. Thank you for watching and please subscribe to my channel so that you won't miss any updates.